Good morning all to the lecture of mechanics of material 2. In the last class we have seen about the concept of principal stress and strain. In order to understand it, I have told you about that in order to get the principal stresses we need to derive a cubic equation, and solution of that cubic equation can be done in various ways. However, a standard method I have shown you. So let's start with the revision of that standard method, and then after we will move forward to some problems related to principal stress and strain. So as you can see that we have an equation like this. We have an equation like this. So this is a standard equation. However, the equation may be little bit of different. So we have to compare this equation in order to find or identify the value P, Q, and R. So once P, Q, and R has been identified, with the help of these we can find A, B, and cos phi. Once cos phi has been founded, we can determine phi in order to get the value of G. And in the final step, we can get the value of three roots as y1, y2, and y3, or as sigma 1, sigma 2, and sigma 3. So in this way, we can do the solution of a cubic equation. So let's see how we can use it in our concepts. So let's take an example. It is likely to determine the principal stresses and their associated direction for the following state of stress. Means for this state of stress, we have to determine the principal stress, and also we have to determine the associated direction cosines in order to define that plane. So in order to do this example or numerical, we need to form a cubic equation first. In order to form a cubic equation, we will be required to find out L1, L2, and L3, the stress invariants. So let's see what steps we will be needing. First of all, we have to form a cubic equation. Then after, in order to form the cubic equation, we need to calculate L1, L2, and L3. And with the help of these, we can find the cubic equation, and with the help of that cubic equation, the roots can be calculated as sigma 1, sigma 2, and sigma 3. And these roots are the principal stresses. After calculating the principal stresses, we need to find out the direction cosines separately for different roots. For sigma 1, we need to find nx, ny, nz. For sigma 2, again we need to find out nx, ny, nz, because with each associated principal stress there would be different planes. However, in order to solve this cubic equation, we need this method. So in this way we can solve the numerical. Let's see how we can imply these steps in order to solve this numerical. So our stress matrix was like this. In order to solve it, first of all we need to compare it with the standard matrix so as to find out the value of stress components. The standard matrix is like this. So sigma x is like sigma x is equal to this 1, sigma zx is equal to again 1, and tau xy is equal to 2. Sigma x equal to 1, tau xy equal to 2, tau zx is equal to 1, and sigma y is equal to this one, and tau yz is equal to 1, and this sigma z is equal to 1. So all the results are being written here. The stress components are this, as you can see. These are the stress components. We have got this by comparing this to this. After doing this, we have to calculate L1, the first stress invariant. That was the summation of sigma x, sigma y, and sigma z, like this, as you can see here. So sigma x equal to 1, sigma y equal to 1, and sigma z equal to 1. So L1 comes equal to 1 plus 1 plus 1 equal to 3. Now in the next step we need to calculate L2 in order to form the cubic equation and all as well as L3. So L2 can be founded as you can see that the formula is sigma x sigma y plus sigma y sigma z plus sigma z sigma x minus tau square xy minus tau square yz minus tau square zx. Or you can also use this method, the cofactor method. You can also use this method or this method. So let's use this method in order to find out the value of L2 or the second stress invariant. For that, sigma x should be multiplied with sigma y. So it is 1 into 1. Then after sigma y plus sigma z, again it is sigma y into sigma z, 1 into 1. Then after sigma z into sigma x, 1 into 1 again. So it is 1 plus 3. This is 3. Then after minus tau square xy. Tau square xy means 2 square. This 2 square means it is equal to 4. Tau square yz means this one is equal to 1 from here. Or tau square zx. Tau square zx is again 1. So we can see the calculation as like this. 1 plus 1 plus 1, that was equal to 3 minus 4 minus 1 minus 1. So finally it comes equal to minus 3. In the next step we have to calculate L3, the third stress invariant, by expanding this determinant. We need to expand this determinant or this determinant. Or this determinant. So this can be expanded by, let me show you how. You have to multiply this 1 by its cofactor 1 into 1 like this. Then after you have to multiply 2 with its cofactor like this, 2 into 1 into 1 into 1, and similarly for this. So finally upon expansion it could be written like this. So it is like this. 1 into 1 minus 1 minus 2 into 2 minus 1 plus 1 into 2 minus 1, so that L3 comes equal to minus 1. So once L1, L2 and L3 has been calculated, we can form the cubic equation. And the cubic equation is like this. F sigma equal to sigma cube minus L1 sigma square plus L2 sigma minus L3. Whereas L1, L2 and L3, the value has been calculated so far. So by substituting the value of L1, L2, L3, the equation is like this. Sigma cube minus 3 sigma square minus 3 sigma plus 1. Because L1 was 3, L2 was minus 3, and L3 is minus 1. All these values have been substituted to form the cubic equation. So the roots of this cubic equation would be the principal stresses, and they will be designated as sigma 1, sigma 2, and sigma 3. So let's see how to find out the roots of this cubic equation. Obviously the method is simple. The simple method is to adopt that general equation. So you have to compare with the standard equation, and the standard equation, as you can see here, this one is a standard equation. So after comparing with the standard equation, we can calculate the value of E, Q and R. So if I compare this with this, then what I can get, P is equal to minus 3, Q equal to minus 3, and R equal to 1. So one can compare it very easily. After that, we need to find out the value of A and B with this formula. A is equal to this and B is equal to this, as we have already the value of P, Q and R. So upon calculation, the value comes like this. A equal to minus 6 and B equal to minus 4. Once the value of A and B has been calculated, next task is to calculate the value of cos phi. For cos phi, B and A is needed, that the value we have already calculated so far. So we can get cos phi as 4 by 2 root 8, or it is equal to 1 by root 2, means phi is equal to 45 degree in the first quadrant. So we have determinant phi. Now we need to calculate the value of g, that is 2 under root minus a by 3. A is equal to minus 6, so minus 6 into minus, so it is positive 6 by 3, 2. So it would be equal to 2 root 2, like this. The value of g has been also calculated. Now next task is to calculate sigma 1, sigma 2, sigma 3 with the help of these three formula. Let's start with sigma 1. So sigma 1 is equal to g cos phi by 3. So g is equal to, this g is equal to root 2. So that's why we have written like this. Then after cos phi by 3, phi is 45 degree, that's why it is 45 by 3, 15 degree. And this p is equal to minus 3. So minus 3, and this minus becomes plus 1 divided by 3, so it is 1. So we have the value of sigma 1 like this. So similarly, we can find out the value of sigma 2. In sigma 2, g remains same. This g remains same, only change is here. 120 plus 5 by 3 means 120 plus 45 by 3, that is equal to 15. 120 plus 15, 135 degree. Similarly, we can find out the value of sigma 3. Again, there is only change here. 240 plus 5 by 3, and again 5 being the 45 degree, 45 by 3, it is 15. So 240 plus 15, 255 degree. So upon solving them, we can get a value like this. So in this way, we can calculate sigma 1, sigma 2, and sigma 3. These sigma 1, sigma 2, and sigma 3 are the principal stresses. The next task is to calculate their direction cosine. So that have to be founded separately. For sigma 1, it is associated with a different plane, sigma 2 is associated with a different plane, and sigma 3 is associated with a different plane. For sigma 1, there are three direction cosines as nx, ny, nz. For sigma 2, there is a separate nx, ny, nz, and for sigma 3, for being the third principal plane, there is again third separate direction cosines nx, ny, and nz. So let's see how we can do. So for that, first of all, we need to summarize all the results. So till now, sigma 1, sigma 2, and sigma 3 are like this, and rest of the results are like this. So let's start to finding the principal plane along the direction, along the principal stress sigma 1. So direction cosine for sigma 1, we have to go through the equation what we have derived in the last class. This equation we have already seen how it has came. In this equation, we need to put the value of sigma x. So sigma x is equal to, this is the value of sigma x, and sigma is equal to minus 1, and x is unknown. Tau xy is equal to 2, and tau xz is equal to 1. Similarly, we can do for other equations. So by putting the value, we can get an equation like this. Now in the next step, tau xy. Now in the next step, we have the value of tau xy. So tau xy is equal to 2. So 2 nx sigma y minus sigma y equal to 1, and sigma 1 equal to minus 1. So again it is 2 nx plus 2 ny plus 2 nz. Similarly, the third step has came. So on further solution, we can get the equation like this. These are the three equations. However, equation 1 and 2, you can see that both are similar in all respect. 2nx plus 2ny plus nz in equation 1 and 2. And we have three unknowns, nx, ny, and nz. So in order to solve it, we need to use the condition of non-trivial solution also. However, with the help of equation 1 and 2, we can get two important results regarding nx, ny, and nz. Let's see what are those results. Solving equation 2 and 3, it is found that nz is equal to 0. You can ask me that how it has came. Let me show you. nz has equal to 0 we have got. Then by using the trivial solution condition, that is nx square plus ny square plus nz square is equal to 1, we can use this. Then after combining the results got in equation 2 and 3 with this, we can solve for the value of nx, ny and nz. So which is like this. Since nz is equal to 0 and nx equal to minus ny, so we can get a result like this. Nx equal to plus minus 1 by root 2 and ny equal to plus minus root 2. But keeping in mind that when nx is positive, ny should be negative. So the final result is like this. As you can see that since sigma 1 equal to minus 1, it is in the direction of plus 1 by root 2, minus 1 by root 2 and 0. So these are the direction cosines for the principal stress sigma 1. In a similar manner, we can solve for sigma 2 and sigma 3 like this. We can solve for nx, ny and nz in similar manner to the preceding principal stress, that was sigma 1. It is like this. So let me show you once again the rough calculation that was for equation 2 and equation 3, as you can see here. So these were the two results. These were the two results, nz equal to 0 and nx equal to minus ny. And how they have came, you can see it and note it down. So this was all for today. Thank you. Thanks for viewing.